We're going to talk about how to do two things on our calculator today. The first is if we're given a z-score, we're going to be able to find the area to the left of that z-score or the area to the right of that z-score, or if we're given two z-scores, the area that's between those two z-scores. The second thing we're going to talk about today is that if we're given area, either to the left or to the right, we will be able to find the corresponding z-score. So let's take a look at our calculator. The function that we'll be using is second distr. The second key is this blue key, and then distr is right above the VARS key, so we can press it. And then first of all, to convert from z-scores into area, we will need to use the normal CDF function, so that's option 2. And then we'll always want to enter our minimum z-score first, and then a comma, and then our maximum z-score. And then we'll close the parenthesis and press enter. And since we're going to be doing a lot of finding the left of a certain z-score or the right of a certain z-score, we will be using negative infinity and positive infinity quite a bit, because if we look at anything that's to the left, that would be negative infinity, comma, whatever that z-score is. And if we want to look at the area that's to the right, that would be that z-score, comma, positive infinity. But it turns out that for the normal distributions, the standard normal distributions, there is so little area that's to the left of -5 or to the right of +5 that we can really just disregard it. Even the tables that give z-scores and that give areas don't count any area that's beyond 4 and -4. And so if we use positive and -5 as our positive and negative infinity, we will be fairly safe. So here, if we want to find the area to the left of z equals 1.25, we could just use -5, comma, 1.25. That will give us 8943, so 0.8943. That means that 89.43% of our data lies to the left of a z-score of 1.25. And then if we wanted to find the area to the right of -0.75, we would do the same thing. Second distr, normal CDF. We do the minimum data value first, and so that's our -0.75, and then comma, and then we do our maximum data value. In this case it would be infinity, but we use 5 for infinity, and close the parenthesis and then enter. That will give us 0.7734, which means that 77.34% of our data is going to lie to the right of -0.75. To find the area between two z-scores, we do again the same thing, second distr, option 2, normal CDF. We enter the minimum. In this case, our minimum, if we're looking between -1.5 and 3, our minimum is the -1.5, and then comma, our maximum would be the 3.00, or just 3. Enter. That gives us 0.9318, which tells us that 93.18% of our data, an overwhelming amount of our data, is between the z-score of -1.5 and 3. And then if we are given the area that is either to the left or to the right of a particular z-score, we can find out what that z-score is. The same function, second distr, will be used, but this time we're going to use option 3, which is inverse norm. So we'll use option 3, and this function takes in area to the left. And so if we want to find the area to the left, we just put this straight in, and so that would be area to the left of 0.9500. We would just put in 0.9500 and hit enter. And that says our z-score for a z that has an area under the curve to the left that's 0.9500, that's going to be a z equal to 1.645. If we want to find z-scores that correspond to area to the right, well, area to the right is equal to 1 minus the area to the left, since the area under the whole curve is equal to 1. And so we can use the same function, inverse norm, second DISTR, option 3 for inverse norm, and then instead of putting in area to the left, we put in 1 minus area to the right, which is equal to area to the left. So when we're trying to find area to the right of 0.8735, we just do 1 minus 0.8735, and that gives us a z-score equal to negative 1.143.